And that's how it swims. Now, because it spins its tail, the tail takes on a corkscrew shape, and it spins it, get this, up to 100,000 times every minute. Give you a quick comparison, the F-15 jet fighter, one of the most advanced jet fighters in the world, its engines only spool out at about 45,000 turns every minute. This outstrips it 2-to-1. This bacteria can swim 15 body lengths in 1 second. So in other words, if you were to keep up, you'd have to swim from about here to those stands in 1 second. Anybody want to try? Don't, you'll hurt yourself. Trust me on this, okay? Now, the Japanese especially are really paying attention to this because what they're doing is they are dissecting it and trying to figure out how it works because they want to copy it. They want to make robots so small based on this technology that they can put it into a needle and inject it into your blood vessels and have it do surgery on the inside of your body without even cutting you open. That's pretty impressive. So what they're doing is they're cutting it in half to see what they can see. And when they take a look inside, this is what they see. It is essentially an electric motor. It has all the parts of an electric motor. The rotor, called that because it rotates. The stator, called that because it stays there. The drive shaft, which runs through the bushing or bearing, which holds the whole thing centered. And then finally, spinning the tail in what many have called a universal joint. Now, you guys think this had a creator, this model, right? What about the bacteria? No. It's as complex. Complexity implies it was created. Let me ask it another way. Can this battery, or can the bacteria assemble itself without a guided, intelligent creator? Does it just fall together? No. It has to have a creator. See, and you guys are just kids. You even know that. Now, here's the catch. Now, if you girls, if you have long hair, you can do this. Boys, don't pull your hair out because then this happens, okay? But if you have long hair, pull a hair around and look at the very tip of your hair. Or maybe you can borrow your friend's hair. Okay, just don't pull it out. This motor is so small, you can fit 8 million of these motors on the tip of one of your hairs. Whoever this creator is a pretty amazing creator. And it demands a creator. Okay, I'm going to do something I normally don't do. Okay, anybody know what that is? Egg from ostrich egg. You got it. Pretty big egg, huh? Okay. I'm going to do something that I normally never do. This is an actual fossil dinosaur egg. This is not a cast. It's the real McCoy. This is a hadrosaur egg. And I'm going to talk about the hadrosaurs later on. That big one down there, that is a hadrosaur, a full-grown one. Oh, that's okay. Wait for it. What I'm going to do is I'm actually going to pass this around. Okay? So you can actually hold a dinosaur egg. How many museums can let you pet their dinosaur egg? Not many, eh? Okay. No, it's not alive. It's very dead. It's very dead. It's very fossilized. So this is an actual fossil hadrosaur egg. I want you to do a couple things, though. Pass it around carefully. Don't hold it above your head, because then you drop it on someone else's head and they get mad at you, okay? So carefully hold it and pass it around so everybody gets a chance to hold it, and don't put it in your pocket and walk out the door with it, okay? So be very careful with it. I'm going to pass it around. I'll start down here. This is what I'll keep. It's nowhere near as much fun as the dinosaur egg. Yep, and it is heavy, by the way. Don't forget, it is a rock. Now, dinosaur eggs tell a very interesting story. And I'm going to use this cast of that dinosaur egg to explain it. Some people have tried to say that there was no past global flood. Now, you guys remember the story of Noah and the ark in the Bible? Yeah? Okay. It's a really big flood, and this guy by the name of Noah built a really big boat. Do you guys think maybe Noah brought dinosaurs on the ark? No? They would eat them? Oh, that's a problem, isn't it? Oh. Okay. Now, First of all, a lot of people say Noah couldn't have brought dinosaurs on the ark. They're too big. I mean, Brachiosaurus was huge. He was like 80 feet long from the tip of his nose to the tip of his tail. If you were Noah, now my Bible says God instructed Noah to bring 2 of every land animal. Are dinosaurs land animals? So Noah's supposed to bring dinosaurs with him. What would you do if you were Noah? Oh, well, that's a problem. Have any of you gotten the chance to clean out a barn recently? Oh, you did? Lucky you. Was it fun? Oh, she's enjoying it. Okay, good. It was fun, right? Can you imagine cleaning out after a barn full of dinosaurs? Ugh. But if I was Noah, you know what I would do? Here's what I would do. I would bring baby dinosaurs on the ark. Think about it for a second. Here's the size they were when they're born. Okay? Here's the size of a full-grown one. Look at the difference in size. This was just its head. Look at how big they grow. So if I were Noah, I would bring the baby dinosaurs on the ark because they sleep lots, they don't eat much, don't take a lot of space, don't go to the bathroom much, that's important. And when they get off the ark, they have a full life ahead of them, right? So now, there is a problem. Noah only brought a few dinosaurs on the ark. He didn't bring all of them. Now, my Bible, where's my Bible? There's my Bible. My Bible says that the floodwaters rose for 150 days. That's 5 months. Shh, careful now. That's 5 months. If you were a dinosaur, wouldn't you have to lay eggs in 5 months? No. Most dinosaurs would. And when you gotta go, you gotta go. So whether there's a raging flood going on or not, the dinosaurs have to do something about their eggs because the water is continually rising until the highest land is covered and the dinosaurs can no longer roam. So here's what they did. Now this is a reconstruction of an oviraptor egg nest. Now the oviraptor egg nest, actually I'm going to pull this off and hold it up for everybody so you can see. The oviraptor eggs, or the oviraptor, it's very interesting how it got its name. It's called egg stealer or egg robber. Here's why. When they first found an oviraptor, they found it with a dinosaur egg nest. And they thought that the dinosaur was stealing the eggs. And so that's why they called it egg robber, oviraptor. Now later on, they found the same eggs as these, only it had a baby dinosaur inside the egg. Guess what kind of dinosaur it was? Oviraptor. It wasn't stealing its eggs. It was a mother sitting on the nest, protecting its eggs from the flood. That's most likely what it was. Now here's what the oviraptor wants to do. And by the way, later on they found a couple of oviraptors actually buried alive, sitting on the nest. That was a pretty fast flood. Now here's what the oviraptor wants to do when it lays its nest. It stands in the middle, and apparently it laid 2 eggs at a time. So you see how the eggs are in pairs? And so what it would do is it would stand in the middle and lay them. It would lay 2 eggs, rotate, lay 2 eggs, rotate, lay 2 eggs. And it would do that in a circle and then make a second level. And then it would sit on the nest much like a bird sits on its nest. Now that's what the oviraptors wanted to do. But here's the thing, when we find dinosaur egg nests, we usually don't find them like this. We usually find them in piles, or in this case, we actually found this egg nest. If you look carefully, the eggs actually rise as they go around the circle. Apparently, as the dinosaur was laying its egg nest, the mud it was laying them in was actually going up. It was actually rising. Again, it's evidence of a flood. This dinosaur here was another oviraptor. Almost looked like this oviraptor was laying its eggs on the run. Why would it do that? I wonder what on earth it was running from. Maybe it was Noah's flood. Maybe. Okay. Now, I'm going to show you something here. It's a little complicated, but I think you guys are smart enough to handle it. Okay? Now, I'm going to talk to you about information. And it's really difficult to grasp at first. Information can be communicated in a bunch of different ways. For instance, it can be communicated on a scroll or in a telephone book. A telephone book has a lot of information, right? Okay? Or sometimes the information can be in a book, and the information is something like, Mary had a little lamb. Its fleece was white as snow. That's information, right? I didn't know Mary had a little lamb. Well, maybe you did. Sometimes the information is in, for instance, a dictionary. There's a whole pile of words with a whole pile of information in there. Where did the information in that book come from? God? Maybe ultimately. Yep. A printer or the writer of the book. Did the information come from the book? No, it came from the person who wrote the book, right? Okay. So, sometimes, do you guys have those walkie-talkies with the button and you can do Morse code? Beep, 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 beep. You have one? Okay, excellent. That's Morse code. So you are communicating information using sound. Just using dots and dashes. 3 dots, 3 dashes, 3 dots means SOS for save our souls. Morse code. Information can be communicated by sound. The internet is primarily transmitting information by light. So if you can understand what we're getting at here, information is communicated. It comes from a person and it's sent to another person. Okay? Now, do these letters contain any information? No? Okay, let me ask you again here. Do these letters contain any information? Yes. What changed? Oh, so the information isn't in the letters. The information came from someone who put the letters in the sequence, right? Yeah. Now, the other way around, if we take those letters and we add more letters, or we take that information and we add more letters, do we get more information? Yeah. No, we actually lose what we already had, don't we? Yeah. So the information is not in the letters, the information comes from outside of the letters. Now it's going to get really complicated. You guys want to impress your parents tonight? Go home and say you learned about deoxyribonucleic acid. Okay? You can say it for short. We learned about DNA. Have you heard that term before? Some of you have? You haven't? Okay. Now, I have a model of DNA right here. This is a strand of stuff that is in every single one of your cells. And this is a series of letters all put together. You know what this is? This is a blueprint on how to build you, or a plant, or a fish, or whatever the genetic code happens to be in. It's a secret code, if you will. A secret code on how to build you. And it's made up of 4 letters, G, C, T, and A. So again, if you want to impress your parents, you can say guanine, cytosine, thymine, and adenine. There'll be a test on this later, especially you. Now, all these letters get put together in a sequence, and it's information on how to build you. Now, you guys told me the information in a book came from the author, right? Where did the information in the DNA, in the instructions on how to build you, where did the information come from? Had to have. It didn't come from the DNA. If you just put a bunch of letters together, you don't have instructions.